Hi, welcome back. Today we need to examine another type of limit that we've talked about in the past, but it's been a little while, and that is a limit at infinity. Now, not to be confused with infinite limit. An infinite limit is when you take a limit and you get either positive or negative infinity for your answer. Remember, that's a special way to say the limit does not exist due to unbounded behavior. With the limits we're talking about today, these are called limits at infinity. We're looking at limits where we are approaching either positive or negative infinity. So remember, previously we basically focused on limits that look like this, where we're approaching some finite value c. But we also need to talk about limits as we approach positive infinity, or maybe negative infinity. Now this first quick video on the topic is going to be actually should be familiar to you, because in fact it's a box straight out of the college algebra book that I wrote for my college algebra students. All I did was I took where in college algebra I would say end behavior is equal to positive or negative infinity or whatever. Here I replaced that with limits, because in college algebra we don't talk about limits because they don't really know what a limit is. But it's the exact same, definition box that I have in my college algebra book, except that it's written in terms of limits instead of in terms of end behavior of a function. By the way, that brings up the point that the reason we talk about limits at infinity is because they're very useful at curve sketching. Okay, we will focus a lot on curve sketching in one of the future chapters, and we want to, when we do that, figure out what the behavior of a function really far, if you have a graph, what happens to the function way over there, and what happens to the function way over there. That is, what happens as x gets really, really big positive, and what happens as x gets really, really big negative. Does the function approach a finite value, like a horizontal asymptote? Does it shoot off to positive infinity? Does it shoot off to negative infinity? What is happening with the function as it goes very far to the right, the limit as x approaches infinity, or very far to the left, the limit as x approaches negative infinity? And that's what we are considering today. There's just two of these limits, because there's two possibilities. You're approaching positive infinity or negative infinity. So it's really every function, not every function, a lot of functions will have two of these limits to consider. Now, think about it. Not every function you should consider both these limits. Like here, I mentioned it in the text. It makes no sense to talk about the limit as x approaches negative infinity of square root x, because that has domain positive numbers. It's not defined for negative numbers, so it makes no sense to talk about the limit as x goes to negative infinity, because it's not defined at negative infinity. So, for all functions, we'll have to just play it by case. But most functions will have a reason to evaluate both limits. Let's talk about polynomials first. Polynomials are defined for all real numbers, and so they will always have some sort of solution for both limits. Like I said, this is the exact box out of my college algebra book. This is referred to in college algebra as the leading coefficient test. So remember, a polynomial is like a quadratic or a cubic or a quartic, where you have polynomials, things that look like this. Okay, and here's what the leading coefficient test says. The leading coefficient test says you first identify the degree. Okay, what's the degree? The degree is the highest power of x. So, like for this first example A, the degree is 2. Now, we don't really care what the actual number is. All we care is the degree even or is the degree odd. Okay? If the degree is even, well, then we have these set of results. If the degree is odd, well, then we have a different set of results. Okay? So let's look at a couple of these examples. Let's kind of talk about the box as we go. So for example A, you first need to identify if the degree is even or odd. So with A, the degree, the highest power x is 2. So the degree is 2. Now, like I said, we don't really care if it's 2. We care that it's even. 2 is an even number. So let's just note even. And now let's focus on this. If a is greater than 0 or if a is less than 0. Okay, what is a here? A is the leading coefficient. What's the leading coefficient? It's the value, the coefficient that's paired with the highest power of x. So in this case, 3 is the leading coefficient. I'll just say LC for an abbreviation, leading coefficient, is 3. I don't really care that it's 3. What do I care? I care that it is positive. And then if you look at the picture, this is basically what the graph is going to look like. Now, why did I put like half of the graph is dashed? Because what I'm saying is I don't really know what's going to happen close to the origin, but I know that overall, if you look far to the left and far to the right, this function's basically U-shaped, going up into the right and up into the left. So what I can do is say, if I know this is the basic shape, that tells me that both limits, the limit is x goes to positive infinity, and the limit is x goes to negative infinity, those are both equal to positive infinity. So the limit as x goes to infinity of, what was it, 3x squared minus 7x minus 1 is equal to infinity. And also the limit as x goes to negative infinity of 3x squared minus 7x minus 1 is also equal to infinity, because we basically have a U-shaped. Now, we actually know more about this. It's a parabola. Okay? Now, we could do some college algebra analysis and find the exact graph, find the x-intercepts. We know that from college algebra, it's a parabolic shape, and since the leading coefficient is positive, it's opening upward. So that confirms our result. It will be basically U-shaped, going off to positive infinity to the left and the right. Okay, what about example B? Example B, we have, what's the highest power of x? It's 3. So the degree is 3, which 3 is not the final information. The final information is 3 is an odd number. Now, what is the leading coefficient? Now, be careful here. Remember from college algebra that the leading coefficient is not the first coefficient you see. It's the coefficient that's paired with the greatest term, the term of highest degree, which in this case, 5x cubed is that term of highest degree. And so 5 is the leading coefficient. So LC is 5, which is positive. So that means I am looking at an odd degree, and the leading coefficient is positive. So that means I have this situation going on. Again, the dashed portion means ignore what's happening close to the origin, but I know that very far off to the left, this function is going down towards negative infinity, and very far off to the right, it's going towards positive infinity. The end behavior, in other words. So I know that the limit as x approaches infinity of 10x plus 5x cubed is equal to infinity, whereas the limit as x approaches negative infinity of 10x plus 5x cubed is equal to negative infinity. And let's fix that. Let's make sure to put a negative right there. That's more visible. Negative infinity. Okay. Now, what about example C? Example C, notice the highest power of x is 4, so the degree is 4, which is an even number. and the leading coefficient, the coefficient that's paired with the x to the fourth, is -2. Negative is the important part there. Okay, so we have degree is even, and we have the leading coefficient, sorry, the degree is even and the leading coefficient is negative. So that means we're dealing with this situation right here. So I know that as x approaches negative infinity, the graph is going off towards negative infinity. As x approaches positive infinity, the y values are going off to negative infinity. So both of my limits at infinity, in this case, are going off toward negative infinity. So we have the limit as x approaches positive infinity of -2x to the fourth plus 6. That's equal to negative infinity, as well as the limit as x approaches negative infinity of -2x squared plus 6 is also equal to negative infinity. Okay. Last one. So what's the combination we have not talked about yet? I guess that should be the last one. Let's see here. We have a highest power of x is 5. So the degree is 5, which is odd. And the leading coefficient is an understood -1. So negative. So in this case, we have a odd degree. Leading coefficient is negative. So we have this situation. So as x, we say decreases without bound, it heads toward negative infinity. The y values head towards positive infinity. As x increases without bound, the y values decrease without bound. And so that tells us our two limits. The limit as x approaches infinity of x plus 3x to the fourth minus x to the fifth is equal to negative infinity. And then the limit as x approaches negative infinity of x plus 3x to the fourth minus, not 5x, that would change the answer a lot, minus x to the fifth equals positive infinity. Again, this video should be largely review. Like, you should know this information already. We're just couching it in terms of limits. Okay. If you're curious, I can either post to Blackboard or give you a copy of my college algebra book that I keep mentioning, because there's lots of exercises. I always include solutions. So if you need to review any algebraic topics, if you don't have your old college algebra book, let me know and I can just post my college algebra book. I don't charge for anything. I write the materials for free, so I can just post that on Blackboard if you want it, and that way you can review these topics. And you'll find this exact box in that college algebra book in the polynomial section. The only difference will be is that I don't use the word limit. I use the phrase end behavior, which basically means the same thing when you're talking about limit at infinity. Okay. Now, this video was about limits at infinity for polynomials, but obviously we're going to work with lots of different types of functions. So we need to figure out how to do limits at infinity for other types of functions, specifically rationals and quotients in general. So in the next video, we'll talk about how to do this, except with quotients, which takes a different technique. Okay. So in the meantime, if you have any questions, let me know, and I will for sure catch you next in our video about rational functions and limits at infinity. All right, talk to you soon.